And so fundamentally, there's this question, what's the right programming model for this? Okay? We don't know. I don't think anyone, there's been 40 years or 50, 60 years of work on parallel computing, and we still don't have a good answer to the question, well, how do we write a parallel code that works and we really understand that it works, that we can have high confidence? There's some trends here, and I won't go into much detail, but basically there's this notion that you have hardware support potentially for fine-grained transactions. You have language constructs that allow you to say, well, abort this thing. I started going down this path. Oh, don't do that. Hardware supports speculation anyway, so there's some mechanism there that already exists. But on the other side of that, we haven't seen somebody demonstrate conclusively that if you had these mechanisms, you could write the code and have a much higher confidence that it was correct. Of course, there's other proposals, things like data parallel languages. But whatever the solution, we have to look at it now because the machines are here. They're on our desktops, okay? And as soon as it becomes hard to sell the next generation of technology because no one's using the other 8 processors, they're using the one, and there's 8 processors that aren't doing anything. There's going to be we're going to need to solve that problem. There's going to be a lot of business incentive to solve it. Okay, so concurrency is a problem. Another problem that I will point out is this collision between the memory wall. So we all acknowledge that the memory wall is, yeah, Mark?
I'm not convinced that programmers can handle multi-threading.
Fair enough. Give me an alternative. No. You will have the processors.
Hold on. What we find in WebSphere is that the WebSphere programmers can handle the multiprocessing, but the people who are writing the individual, our customers, cannot. Mm-hmm. So what we do is we have WebSphere handle it for them, and we don't expect parallelism in the transactions themselves. We expect WebSphere to be in control of them. And we've actually had people saying we should have rules which say, if a programmer ever forks, other than one of our blessed super programmers, we should tell them they should stop doing it. and they still get a substantial amount of parallelism. If you're doing that in the OS, you can do OS-like things in one core and non-OS-like things in another core. And until we get to substantial degrees of parallelism, factor 40, which isn't on our desktop yet,
yeah,
you can probably
only
get
a number
away
of
with
years.
He says we need some language-based solution to the problem of concurrency, and you're proposing an architecture which is to actually modularize in such a way that some parts of the program don't appear to have concurrency at all. I mean, this is a solution.
Yes, but it's probably not the one he was thinking. He was probably thinking that he'd actually let people do it.
Well, here's another way to think about it. Is that for certain kinds of applications, that architecture is great. But because there's a lot of inherent parallelism in the application, right? You've got just like databases. If you've got 1,000 independent transactions going on, serialization works and you can do all the tricks, right?
Right.
But when you're trying to implement a desktop productivity application, all of a sudden, how does that model fit with the fact that you've got to repaginate a page, or you've got to add characters, or you got to do the spell checker? I mean, these are all questions that have to be answered because that power is going to be there, right? And if it's not utilized, it's going to be on your desktop.
Sure.
This is the amazing thing that, from my perspective, about this Intel announcement. Essentially, they're saying it's not going to just be in the server; it's going to be on every processor we make. Okay,
sure.
It's going to be on your laptop. Yeah.
So I could say a lot of things. I could say this: that you might remember, because everyone knows this fact, that what percentage of people can get a binary search right? Something on the order of 12% is the number that sticks in mind. What percentage of people can make any multi-threaded operation program work correctly? Maybe half that, but only half that. Same order of magnitude.
The numbers are high.
The way you solve this is, you do the hard parts for people, which I think we're agreed. But I think that if you say it this way, that other people won't disagree with you.
Okay, so I'll make another point. I think this is something to take away. So we know about the memory wall. We know that it's there. We know that I/O is the sort of first generation of this problem, and we have to solve that problem. But it's that's just going to be the first wave, and then it's going to be the 10,000 cycles to the L2 cache or whatever. That's going to be the problem. But realistically, we've got some ideas here. But and there's some improvement in terms of locality. But the other side of that is there's a trend in metadata to actually have more and more data at runtime. Okay, and all the presentations, very few people focus on the memory footprint or the locality pattern of the memory in terms of adding things like an optimizing compiler or adding new mechanisms that allow you to express privacy concerns. Okay, all these mechanisms, reflection, dynamically generating new classes. Well, what does it look like when you start touching the memory required to do the checking and to load in the metadata that you need to check to make sure that that new thing you generated actually is conformant to the interfaces that you've specified? See, so I call this the metadata scale problem. The more and more you use this metadata, the more data you need to access at runtime, and it's not data that you're going to use in the same kind of locality pattern. It's going to be data that you use very occasionally, and in fact, that works exactly against you because the cost of accessing becomes very high. So anyway, I would argue here that reflection is extremely flexible, and I think we've moved into a space with reflection that is just assumes everything is dynamic, that we can do anything we want. I think that we need much more discipline in that space to understand what the costs are and the benefits. So rethink metadata availability at runtime. That's one of the takeaways, and I think that this is necessary. I mean, if you can solve this memory wall problem some other way, hey, great, that's awesome. But if you can't, and I don't think anyone's got a magic bullet, you have to rethink this. We have to show some discipline. Okay, and so what does that mean? Better static checking, better tools, trying to understand static versus dynamic checking. Yeah, man.
I don't quite understand this argument that Intel's going to build this hardware and the world will come to an end if they can't take advantage of it. Like, for example, if somebody built a 64-bit machine and you weren't saying, okay, we need to start using address space really quickly so we can take advantage of those upper 32 bits.
It's obvious what you do with the extra 32 bits, though. Right? See, that's the difference. There was a huge demand. There is a huge demand for 64-bit address space because there's a lot of people that need more than 32 bits. I guarantee you. From a business point of view, there are a lot of people. Okay, but I don't hear as many people with a desktop system saying, God, if I only had 8 processors, I'd be kicking butt.
Well, the other way to look at this is, too, how tangled up do you get going from 32 to 64 bits versus going from 1 to 2 processors?
Yeah.
So the argument that Intel will build this CPU, if there's not the thread level parallelism to take advantage, it'll be like a Tinian, a mistake they made, and they'll go back and try some
well,
other
anyway, I don't want to say anything. What I will say is that they have said they will build it, okay? And it will be built. Now, if it's a mistake, if you're like you're saying, okay, then the question is, what else are they going to build?
Right. That's the real question.
It's like, okay.
Do they have a choice?
But I also
A quick comment I'll make is,
cost.
even if they don't build a multi-core CPU, they'll build something that's explicitly parallel. Because virtually every research project out there in architecture today is explicitly parallel, where the parallelism is exposed to the software.
Well, but I think for Intel to produce a 4-processor chip will cost them, 20% more than producing the 1-processor chip of the same processor speed.
But the process is also changing,
right? I mean, what they'll be doing is producing 6-processor chips, of which 2 are failed. And so it's not that they're doing it because they're doing it because it's the cheapest thing they can do.
Well, but the subtlety here, right, is it's not just there's multi-core chips, but each of those cores is going to, either shrink in performance or grow very slowly relative to the core speed
But
growth
that would be
you
true
see
whether there was
today.
1 core on the chip or.
No, right. Well, no. I mean, today you've seen a growth curve. That growth curve is going to flatten.
It's going
And
to
it
flatten
might
whether or
even-
not they put.
It might even go down. Depending on the trade-offs they make in the design of those cores and how many cores they get on a chip and how much cache you have to share. But the point is that.
So,
but
can I
exploitation-
charge forward just because I have some other things to talk about, and I think they're also interesting.
I'll try hard again to help you out here. So don't worry about the other programmers. Just think, well, oh, good, now we can have a dedicated compile thread. Oh, good, now we can do fully concurrent GC. Use the threads in the VM. Don't worry about the programmer. But you got to get that code right, and that's the key, right? Somebody's got to write the code, and it's got to be correct, and that's the hard problem.
Okay, let me talk about error recovery very briefly. This isn't an area that people have invested heavily in, but it's a very important area. Exceptions are not the ultimate error recovery mechanism. There's a real problem with this notion of data consistency. When you have an exception, all it does is say, hey, whoa, control, something went wrong. It doesn't tell you that you're in a consistent state. Again, databases have transactions. It puts them in a consistent state. And so we have to really think a lot more about increasing the granularity that we reason about programs. It helps the programmer. It also helps tools. And something I haven't said a lot about, but I want to emphasize is the